So, geez Louise, 1, 2, we talked about vertical angles. They're always congruent. And now we're just going over parallel lines. We have a diagram here. We labeled it as such. And then we said alternate interiors would be 3 and 6 and 4 and 5. Alternate sides of the transversal, but inside the parallel lines. And alternate exteriors, same thing. Opposite sides of the transversal, but outside the parallel lines. So we just said 2 and 7 and 1 and 8. And we determined that they are also congruent. Now, corresponding is a little bit different. Does anybody remember what corresponding angles do? Or what they are? Or could you give me an example from this diagram? No, those are going to be supplementary. Yes. Basically, they're in the same spot, but a different location. So 1 is in the top left of his little group, and 5 is in the top left of his little group. So it's like if these are seats at prom and you're picking your tables, it's people that would be sitting in the same seat, just at a different table. Okay, so corresponding 1 and 5. And there's lots of them here. 1 and 5 are an example. 2 and 6 would be another. 3 and 7. And 4 and 8. So, let's talk about their measure. Corresponding angles. Same measure or not? They are, yep. That's another thing you proved in geometry. So they are also congruent. Okay, and then this last one refers to same side interior. So if we had to guess, same side interior. So interior we already said means in between the parallel lines. But now same side, well now I just want 2 on the same side of the transversal instead of alternate. So in this case that might be 3 and 5 or 4 and 6. But do they look like they measure the same? Look at 3 and 5. Do you think that those are, their degree are equal to each other? No, but what might be true about them? They must be supplementary. We already talked about how the corresponding angles are the same, right? So 1 and 5 are going to be the exact same measure. And then when you can see very easily here that 1 and 3 would add up to be 180. So they will be supplementary. A nice way to remember that is that same sides are supplementary. You have that S alliteration. There's also same side exterior angles, which are also supplementary. For whatever reason, they're not on your notes, but they exist too. So same side exteriors. Oh, hi, Evan. Same side exteriors would be something like 1 and 7, 2 and 8. They're just on the outside of the parallel lines. Okay. And, oh, I think we can finish before lunch because this last little bit, you know. The sum of the interior angles of a triangle add up to, if you add up all the angles, what'd you say? 180, right? It's just add up all the angles in a triangle. They sum to 180 degrees. And then we're just going to classify triangles. Remember that there's 2 different ways, by sides and by angles. So, they have angles first. So, do you remember the words to classify by angles? Triangles. Think about how you can classify triangles. I'll give you a hint. One of them's right. Right? A right triangle, you can also have, you're right, but that's about sides. Right triangles, what is it when all the angles are less than 90? Acute. And the other one is obtuse. And I assume we all remember what this means? Right triangles have exactly one 90-degree angle. Acute, all less than 90. Obtuse, one is greater than 90. And then by sides, you said isosceles, right? Isosceles? What are the other words? Scalene and equilateral. Yes. Do you remember what these all mean? Isosceles means you have at least 2 sides congruent. Remember that symbol for congruent, the equal sign with the squiggle? Oh, you can't even see. Remember that? Scalene has no congruent sides. And equilateral, of course, has all congruent sides, yes. And let's just see if we can finish this page real quick. Similar triangles have blank corresponding angles. Anybody remember? Reach back in that geometry brain. If you have two similar triangles, what's the deal with their angles? I'll give you a hint. Similar triangles might look like this. You might have like a little one and then a big one. What's the deal with the angles? They're the same, exactly. Similar triangles have congruent corresponding angles. And what's the deal with their sides? Because the sides are certainly not the same, but they are. Yes, they are different, but there's a fancy word that describes what they are. Like, what's the word that's like, if I took all of these sides and multiplied them all by 2, I'd get this one. Oh, shoot. I guess ponder it during lunch. And we'll talk about it when we get back.